in this example, we're going to be showing that this 3 by 3 matrix has no inverse. For this 3 by 3 matrix, the first row is 3, 2, 5. Second row is 2, 2, 4. And the third row is negative 4, 4, 0. We're going to use the same technique as what we've been doing so far. We're going to take A, we're going to augment it with the identity matrix. We're going to attempt to take it down to reduced row echelon form. But the way that we can show that this has no inverse is that in reduced row echelon form, we'll show that it's impossible to get the identity matrix to the left of the augment. Now, as such, we will start the same way. 3, 2, 5, 2, 2, 4, negative 4, 4, 0. Then we'll augment with the identity matrix. Now, our first goal for reduced row echelon form is to get a 1 into the 1, 1 entry. Now, you are technically allowed to use any elementary row operation to do so. The one that I'd like to use is I'll use the 2 that's right below it and subtract the 2 from the 3. So we'll take negative row 2, add to row 1, and that'll become the new row 1. So overall, the second row is staying the same, and the third row is staying the same. And we'll take negative 2, add to 3, we'll get 1. Negative 2, add to 2. Negative 4, add to 5. Negative 0, add to 1. Negative 1, add to 0. And negative 0, add to 0. Boy, that feels weird to say negative 0. Now that we have the 1 in the 1, 1 entry, we're going to use that lead 1 to get zeros into the 2, 1 and 3, 1 entries. So to clear out the positive 2, we'll take negative 2 times the first row, add that to the second row, and that'll become the new second row. And we'll take positive 4 times the first row and add it to that fourth row. Third row. How many rows are there? 1, 2, 3. Third row. Yeah, 4 times the first row. Add to the third row. That'll become the new third row. Sorry about the mental fart that everybody just got to witness. That was fun. So overall, first row is staying the same. For the second row, we're doing negative 2 times the first row and adding it to the second row. So negative 2 times 1, add to 2. Negative 2 times 0, add to 2. Negative 2 times 1, add to 4. Negative 2 times 1, add to 0. Negative 2 times negative 1, add to 1. And negative 2 times 0, add to 0. Next, we take 4 times the first row and add to the third row. 4 times 1, add to negative 4. 4 times 0, add to 4. 4 times 1, add to 0, we get 4. 4 times 1, add to 0. 4 times negative 1, add to 0. 4 times 0, add to 1. At this point, normally we would try to get a 1 in the 2, 2 entry, but I think that I see something that's going to save us a little bit of time here. We need to show that what we have to the left of the augment cannot be reduced down to the identity matrix. Generally, that means generating a row of zeros somewhere in here. I can do so by taking negative 2 times the second row, adding it to the third row, and have that become the new third row. Now, this technically won't be reduced row echelon form. It'll just be enough information for us to verify that A has no inverse. So the first row stays the same. Second row is going to stay the same. 0, 2, 2, negative 2, 3, 0. The third row will be taking negative 2 times the second row and adding to the third row. Negative 2 times 0, add to 0. Negative 2 times 2, add to 4. Negative 2 times 2, add to 4, we get 0. At this point, we're technically done with the problem, but because, I like doing this, I'm just going to take it all the way here. Because we wind up with this row of zeros to the left of the augment, this is what verifies that A has no inverse. So we can't obtain I to the left of the augment. Therefore, A is non-invertible, or singular, which is just a fancy way of saying A has no inverse. That'll show it to try to be something that it's not.